Okay, everyone. I just have a short announcement before we start back. My name is Justin Tonra. I'm at the University of Galway, which is one of the partner institutions of CLS Infra. And I wanted to say a little bit about our Transnational Access Fellowship Program. You received a flyer about this in your welcome pack. But just to say a little bit more about this, this is a scheme that we run every 6 months within CLS Infra. The third round of fellowships, or is it the fourth round? Sarah, is this the fourth round? It's the fourth round. Is currently open and will close to applications towards the end of this month. And the idea behind the fellowship is that it allows applicants to spend some time at one of the partner host institutions, of which we have 6, including Galway, Trier, Potsdam, Madrid, Ghent, and Charles University Prague, and Vienna. So we have 7. Yeah. So you can apply to spend some time at one of these institutions, learning a particular tool or method that is associated with our program. For instance, you may want to spend some time learning Stylo, for instance, or to just generally get some time to focus on dedicated research and have conversations, illuminating and enlightening conversations with members of CLS Infra. So there are further details for this Transnational Access Fellowship, which is very generously remunerated. There is a stipend that you are paid for the duration of your fellowship, which can last for between 4 and 12 weeks in the host institution. There are further details about this on our website, clsinfra.io. We have a current TNA fellow in Khanim over here. So if you'd like to speak to her about the application process or about her experience, I'm sure she would be glad to chat about that. Some of the hosts are representatives from the host institutions, like myself, Martin from Prague, Salva from Madrid, of course, are here if you want to speak to us as well during any of the breaks. So I won't detain you any further. Let's get back to Stylo.
Hope you're ready. Let's get some more experience into our hands. I hope everything is more or less working for everybody. I will quickly go through where we ended, so the functions of Stylo, the parameters, and so on, and then we'll quickly wrap up the what different kinds of results you can get and how to analyze them, how to understand what you're actually getting. So if you want to follow directly as we were doing before, just select Stylo, and now a potentially important thing, because some of you asked questions in the break, like how to stop Stylo from running if accidentally we gave it a task that might be too difficult to compute, like a super long experiment. And the easiest way to do this is to just press Ctrl+C. Ctrl+C. 2 buttons. On Mac, it might be that you also need Command button, but at least on Windows and on Linux, Ctrl+C will be enough to break it. That's also universal for, in general, stopping any kind of programs running and also in Python, I think. So that's a very useful combination to remember. Ctrl and C. Okay, so we're running Stylo. We have our parameters window. I hope you can see on your screen, because as said, it's pretty small here. And here, as we talked, we know the first section is pretty clear. I will quickly go through features again, because I know it was fairly rushed and some of you had some questions about this as well. So first we can select between words and characters. And as we discussed, characters are more useful for non-Latin languages, but also if you have a lot of language variation. Also, lots of studies examining historical variants of language use character engrams. There are some very interesting studies about this, and we can link some studies later as well if you be interested in this, so that you can continue learning more about different experiments. With most frequent words, as you remember, you have the default of 100 words, but you can set minimum and maximum to different values, and then you will end up with a series of experiments, so a couple of them. And you can, of course, also make them smaller. So you can also see how your classification would look if you just used 10 most frequent words, for example, or 5. It will not be maybe very informative, but and like about authorship, for example, but it might still give you some idea how things differ. You can also use your existing word list and frequencies, either to just quicken the experiment, but also let's say that you are interested in the use of very particular words across your corpus. So you could just upload your own word list here, artificially created, so that you would just have a notebook with different words that you are interested in, and then you can choose to examine just them. There is also the function of culling. And we talked how culling is helping you remove some of the words that only appear in a very, very small portion of your text in the corpus. So with culling, you can set different values. We usually don't recommend going over 50% because then you will have very few common words between the texts, but you can experiment with different values for yourself. And again, if you set different values to minimum and maximum, you will end up with a series of experiments for different values of culling. So if you choose to save a picture, you might end up with a couple of pictures that will give you different results for that, or that will give you a combined result at the end, depending on the statistics method that you use. So far, so clear? Okay, great. I'm very happy that you guys are with us and giving me, the feedback that that you're listening and understanding. So now the hard part that miraculously we don't have to do, thank God, thanks Stylo, the part statistics. This is one of the most important parts of our experiment. Usually when we do different experiments, we change things in features and in statistics between different runs, because these are the ones that will influence your analysis the most. And in statistics, you have different kinds of analysis. These are all the methods that are used in natural sciences, in general statistics. So there isn't really something new here, because cluster analysis or multidimensional scaling or PCA, these are all methods that have been long proved to work well for examining statistics of various features in various phenomena in the world. One new thing here is consensus tree, and Artyom will tell you a little bit more about this in a while, because this is related to making more reliable results and getting good results faster, which is usually what we want, right? And something that's important for us is the delta distance. So you already know Barrow's delta. So this basic means of comparing text based on the word frequencies using z-scores and stuff. Here it's implemented as classic delta. So what you see as classic delta, this is the Barrow's delta. And this is a good enough method to use in general. There are some other methods for those of you who feel more adventurous, but they are not necessarily fit for all of the types of analysis that we're making. In general, we recommend sticking to classic delta or cosine delta in most experiments, because this will be the most informative, and this will be enough for 99% of the analysis you can think of. But still, the options are there if you want to change something. There is also the option of sampling. And we already had this question a couple of times, like what to do if my corpus has texts that are longer, shorter? How do I approach this? Is it influencing the analysis? And the answer is yes, it might be influencing the analysis. There are different studies on how short the text can be, and there are, so that the analysis is still good. In general, if your texts are at least 1,000 words, it should be fine. Going below this requires some attention and thinking a lot about specific methods and settings, but it's also possible. But I guess that most of you will be working at least with like news magazines or Tim, could you make it smaller?
I'm sorry, no, I just wanted to make sure that
or on your laptop?
Yeah, sorry.
No problem. I guess that most of you will be working with articles or novels and so on. And in novels, it's enough if you consider not putting together novels of like 100 pages and 1,000 pages, because then you can imagine that the novel that will be longer will have certain words used more often, will have more lexical richness, so more unique vocabulary that will be influencing everything. But the difference is like having the novels of 200 pages versus 300 pages will usually not be a problem. So this is fine. But if you're using text of mixed length and you have to use it like this, or maybe you are curious of whether the novel is consistent in style across all the chapters, you can use sampling. And there are two types of sampling that we are interested in. One is normal sampling, which means that the whole text gets cut into even pieces from the beginning to the end, and we use the whole text in entirety. And then we just select normal sampling and determine the sample size. For example, 10,000 words or 1,000 words or 50,000 words, it's up to you. Or you can use random sampling, and then you need to determine the number of samples as well, which would mean that Stylo would select a few pieces of the text of the size that you give it randomly. So it might be that you will end up with 3 samples of 10,000 words taken from the first half of the novel, or one from the beginning, one from the middle, one from the end. You don't know this. This is random. But this can also be useful if your texts are uneven and you just want to have some sort of signal for each novel in your collection. So these are some ways to approach different lengths of texts. And finally, we have output. And this is something that's also very interesting to us. By default, Stylo is giving you an on-screen graph representation of your results. For example, if we used cluster analysis, we got this tree picture. But let's say that we want to save it as PDF, or we want to save it as a picture that we can later put in our paper. And then you would want to save it as JPEG or PNG. The difference is that PNG has transparent background, so it might be more useful, for example, for the website, because if your website is, let's say, blue, then the background of the graph will be transparent. SVG is another format that's usually used for website. You can also save it like this, but it's probably less common. You can also select how big you want your graph. So if you have a lot of text in your corpus and you need a bigger resolution, you can increase here. You can also change the font or make your plot area. Let's say you don't want colors, but you just want everything to be black or black and white. You can also select it here. With PCA analysis, you can also choose different options and stuff like this. But since we're not covering this too much, then I will not focus on this. But what you want to look at is the last line, the various options which give you the option of switching your tree representation from horizontal to vertical. And in some cases, this will be useful for you. Like it might be easier to read it in a different orientation. And you can choose to save distance table, features, and frequencies, which are all very informative, because this will give you the list of exact features that were used to conduct the analysis. or exact frequencies that were computed. And the distance table especially can be interesting for comparing the closeness or stylistic closeness of particular texts. So let's try to save all three of these now and a PNG and select OK. Apart from it, you don't have to change anything. Statistics and features can stay as they were, but let's just save these results. And once this computes, I would like you to open the folder, not the corpus folder, but this main folder that you have. So CLS Stylo Madrid, where you have your corpus, you have your primary set, secondary set, and so on. And now you should see a couple of new files appearing here. And this is precisely why we want to maintain the structure that our texts are safely hidden in the corpus folder, because this way they won't be mixed with the results. And now you can look at Stylo config. This is a file that saves all of the information about the particular settings that were used. So this is useful because, let's say you've done some studies now, but half a year from now, you might not remember what settings you used. Having this file will help you recreate your experiment and remember what happened. Another thing that will be useful, having a picture, of course. It's nice to open it in different programs, look at it, get it bigger, and so on. This is very comfortable. And yes, and you end up with a word list. This is the file that I mentioned that you can also adjust it for your needs. So here we have the cutoff, by default is 5,000 words. So now we have the 5,000 words in the order in which they are appearing. And you can see that I wasn't lying to you. And really the words in the top of the list are pretty common, the, and, to, of, I, a, and so on. But let's say we don't want these words, and let's say we want to try out what I mentioned. So I will just copy this and delete everything. And now I will put word cat, dog, house, man, women. Let's say just this. And I will save it because I will show you how to run your own word list. And as mentioned, the table with frequencies will be super interesting because now you have the percentage use of each of the words. And you can just copy paste this into your Excel, JSON, whatever you prefer to do for the analysis. And then you can also further analyze the differences in relative frequencies. This is maybe for people who are more interested in the nits and grits, but feel free to use it as well. It's very useful, especially if you use phrases and you want to examine how various phrases change. The table with frequencies. I just opened the file table with frequencies. No, the word list. I just removed all the words, and this is Ctrl+A. So yeah. No, I just
copied header.
I just copied the header to make sure it's still there. I mean, it's not needed, but I wanted it to still be relevant in the way that we did. So now my word list looks like this, just 5 words. And as I run it, I'm not changing anything apart from using existing word list in the features section. So now it should be quite fast because it's only comparing 5 words. And let's see how it will look. Or maybe not fast, you know, my computer is slow. But feel free to like put whatever words you want there. You can choose random stuff. Now we're getting somewhere. And see what happened? Our classification got pretty messy. We no longer have this very clear that, in general, also how to read this kind of graph. you see the 0 on the right, and the 0 marks that the two texts are exactly the same. So the further they meet on some branch, the less similar they are. If they meet very close to 0, and this kind of line is marking that they meet, this means that this is their level of similarity. So here we can see that that when it comes to the use of these words, things get messy. It's no longer according to the author, but perhaps to some subjects, topics that are present in the texts. But you can experiment how you want. You can change, for example, look just at the personal pronouns, or just at the articles. Basically, your imagination is the limit at this point. Questions? Or clear so far? Amazing. Cool. So I will just show you a few more slides. Sorry.
What the scale at the bottom represents, those numbers from 0 to 6, please.
Yeah, so 0 marks that the texts are identical. Basically, occasionally it will happen that you make a copying error, for example, and you put the same text in 2 files. And if your texts meet at 0, this is always suspicious. Your text should never meet at 0 unless they are identical. So the further they meet from the 0, the less similar they are. But because this is all relative, you also have to consider that whatever you put in your corpus is the skyline here, the background of your project. So these are all relative similarities. If you have text that will be very, very different, like let's say throwing cookbooks and historical novels together, these texts are not supposed to be similar, but still cluster analysis will always connect them. They will always meet at some point. So just if they meet pretty far, like, I don't know, 6 or 17 or 123, this means that they are pretty not similar. But if you have text that will be very similar, like let's say you examine a collection of letters by one person, then your scale might be 0 to 1.5, for example, because these will be very, very similar texts that will have very small distances between one another.
Yeah, if I may.
Mm-hmm.
So these numbers are just the derivative from the distances in the distance matrix, right? So they're not exactly the same numbers because of how the hierarchical clustering works. But basically, the farther they are connected, the further they are, in the space, in the feature space that you that you defined, right? So the closest text here would be like, the tech arrays, the blue tech arrays, I think, and the farthest away would be these clusters, 2 larger clusters that are connected. They are connected at 6, right? So the maximum distance between these clusters, but each of these clusters is like around 2 or something like that.
Yeah. Yeah, and this type of analysis is often called a tree. Because you can also see this tree structure here in a way that every text is a leaf of our tree. So some leaves will be on the same branch, which means they are very close neighbors. They are very similar in a way, at least they have similar features, like sharing the same branch. But some of the leaves will be on the same tree, but this will be 2 completely different branches. Like in this case, you can see those 2 big branches that will divide our texts into 2 types of text.
May I also, could you please explain what increment does in the features in the Stylo thing?
Yeah, so incrementation is a concept that's quite present in mathematics and in computer science, which means that you are increasing each time you do something. So by incrementing, you're always adding you have the even distances between every new analysis. So let's say you have 100 and 1,000. Maybe I will show it on an example, just a second. So cluster analysis now. Let's put most frequent word settings 100 and 500. And we're incrementing by 100. So in every step, there will be 100 words added to the new experiment. So first we will have one analysis done for 100 words, then 200 words, 300 words, and finally 500 words. So we will end up with 5 analyses total. You can think about it like the dividing maximum by the value in increment. And let's just show how it will look. So we have the PNG saved still. I will maybe use existing frequencies now also to make it faster. Yeah, and now I should end up with 5 pictures. Sorry, I cannot use the existing word list. Yeah, because it only has 5 words. So just a second, and yeah, now it should be good. So, or not. Let's look at this. We are breaking Stylo in all the new ways. Maybe I cannot use the frequencies now as well because I already wrecked them. So the minimum is the first analysis, the first step, and the maximum is the value you want at the end in your last analysis. So you give the starting point and the ending point. You could also have, let's say you're interested in seeing how things will change when you go by 20. So you go from 100 to 500, but incrementing by 20. So it would be 100, 120, 130, and so on. You could also start at 1 and start from 1 word and see how this will increasing. So basically it's supposed to help you save the time so that you don't have to manually do it every time and run Stylo 10 times doing the same thing, but you do this all in one run of the command. Yeah. And this will also come in useful for the bootstrapping, which we will mention in a second. And yeah, sorry, this is a slow computer, but see, now I'm demonstrating that it can take a lot of time. And maybe also an important notion, there is this word appearing here, tokens. Tokens versus type is an important distinction as well. So type is a unique word that you have, so the unique word form, but token is each appearance of the word. So you can have, so basically the word list that you have, this is a representation of types. It gives you different types of words, so unique forms. But as you know, each word might appear even a couple of thousands times in your text, in your corpus, or in particular text. So then this will be the tokens. The value that the word D appeared 3,000 times, this is that we have 3,000 tokens of the type D. And this is also well described. I don't want to overburden you now with a lot of things, but yeah, so let's look at the output of the incrementation. So this is our analysis when we have 100 most frequent words. And now we also have another picture. This is for 200 words, for 300 words, for 400 words, and finally for 500 words. And you can see that some texts tend to realign because the longer the vector you have, the more words are to consider. So we're using different values of most frequent words. If we have just a few, then there are fewer things to differentiate the text. But if we have a longer vector, then there are more things to consider for the analysis. Yeah, but hopefully this is not too much yet. Yeah. Okay. Can I have 5 minutes yet?
Feel free to.
Okay. Then
there's no rush. There's actually some questions but I will take them later.
Okay. Okay. We will come back to them. I just wanted to touch upon 2 more things. So I mentioned the cluster analysis so far, but you also saw multidimensional scaling, PCA, and this is because we have different ways of approaching the distance. We can look at it in the perspective like a tree graph, but we can also look at PCA, which will be a spatial representation or multidimensional scaling. And basically, yeah, we engineer dimensions sometimes too. So the different types of analysis you can do with Stylo, with the basic Stylo or cluster analysis that you already know, you've already produced it. It's a graph like this, a very basic, simple one, quite easy to read. But then we also have PCA, which can be useful as well for analysis of smaller data sets. And PCA is a spatial representation that basically tries to find two dimensions that will best show the distances, the differences between the texts. So you see now that it might be easier to see that some texts are very similar. Like we know that texts by Bronte sisters are actually quite similar stylistically. They had the same education background and they used very similar vocabulary, so they will be closer together. But now we can see that some of the texts are actually quite far. So this might sometimes be easier to read than the tree representation. And here it's important to understand that the dimensions don't necessarily have the same importance. If you look at this representation, you have PC1 that covers 23% of the variance, and the PC2 that covers almost 14%. And this means that the horizontal is the more important. So any distance that you have in the horizontal is more reliable, more important than the vertical representation here. The problem with dimension reduction is that we're always facing some information loss, and you might remember this from the maps in general. We all know the globes, the globus figurine. Most of us had them as children and so on. But we know that this is not exactly the accurate representation of the Earth, because Earth is actually not a perfect sphere, but it's a little bit flattened. There are maps that represent it a little better, but still there is always some bit of information loss because we cannot really represent it properly using either a globus or a map. And this is why there are different ways to approach this, to cover this. And one of them is that we never rely in our analysis on doing just one experiment with one settings. Because you already saw that if once I switched from 100 most frequent words to 200, 300, and so on, the results started to get a little bit different. Maybe these differences weren't very significant, but they were definitely there. And one way about approaching this is the bootstrap consensus tree, the bootstrap representation, which also runs a series of analysis in the background, but then gives you the combined result. Like in this case, the bootstrap consensus tree in Stylo would be a result of running a series of experiments and finding on which connections it agrees that they are the most important, they are reliably, repeatedly considered as similar. And this kind of analysis then is a little bit easier for us to trust, let's say. Yeah, that's a very good intuition. And actually in stylometry, when we do network analysis, we're usually relying on some sort of bootstrapped results. For example, bootstrap consensus network can be the base for building a network as well. Yeah, so thank you for that question. Yeah. And
can I ask,
yeah.
Is there any reason to use the individual graphs rather than the bootstrap consensus?
They are much easier to understand. And if you look at the bootstrap consensus tree, it's very difficult to say when it has its center, isn't it? Like, is the center here, or maybe is it here? Like, this graph is not so bad, but still it can be quite tricky. Plus, you see that some texts are similar, or you see when they are connecting, but you don't see the size of the difference. And when you have the cluster analysis, you can see that some distances are much more significant. But still, cluster analysis is very nice for understanding things. But once your data gets big, like you can imagine that representing 27 texts here, this is okay, right? We can read this graph. But if you put 100 novels, this is already getting a little bit difficult. If you put 1,000 novels, I promise you won't be able to understand. Like, colors help a little bit, but it will be very difficult to distinguish particular names of the files. So then network will be your friend, because it will actually help you see how the texts are positioned to one another. We don't have the time to cover networks, but you will find some resources on our website as well on how to do this. So if you're interested in this, you will be able to follow up, I think.
Can you go back to previous slide? So this one, as I understanding you, is that the hierarchy is in a way that the most important again, using the network analysis, logic, the ones that are on the top are having the most close-knit connections? No. So it's not the same logic.
No, the order from top to the bottom doesn't matter at all to us.
I see.
What matters is how close they meet to zero. Like if two texts meet at 0, it means that they are identical.
Okay.
If they meet at 0.5, it means that they are quite similar, very similar. But if they meet at 2, it means that they are somewhat similar, but not so much. So, the order from top to bottom is completely random.
Okay. And this is the only type of image that one can get out of this Stylo, right?
No. You can get all of these images that I showed you. So you can also get this PCA. This is the result of PCA. Also, feel free to experiment this either today, tomorrow. We're also here tomorrow. So if you do some experiments, you can say to us, come and look, and we will do. So you can also produce all of this different kind of, I'm showing you all the different kinds.
Okay, thank you. Thank you.
So you can also produce this, and this would usually be the first step towards building a network. And you can also produce multidimensional scaling and TSNE, but I will not go into detail of this so as not to confuse you. But before I hand into Artyom, just a few words about designing your corpus, because there were also quite a few questions about this. So Artyom already covered that stylometry has many applications. You can use it to study genre, gender signal in the older text, not necessarily in the contemporary literature. You can examine authorship or chronological patterns and so on. But very often you just want to use stylometry for exploration. So perhaps some of you are building some dataset collections in your home institutions, and sometimes it happens that you have a very big dataset and you don't understand what's going on there. So you want to see something to get to know it better. So this is very helpful for detecting patterns in big data as well, and addressing problems in your data. As I already mentioned, if the texts meet at 0, 99% of the cases will be that there is some human error in copying files or in preparing the data set. You can also use it to visualize large landscapes of data. And we're not covering networks here. You can go to them on your own. But this is one example. My colleagues ended up with a very big data set of American drama, like 2,000 plays and dramatic pieces from the late 18th century up till mid 20th century. And they had zero idea what was in this data set, whether the texts were similar or not. This graph is absolutely useless when it comes to citing it in research. This is bad stylometry, bad study. You cannot show it and say this is the landscape of American drama. But this is perfect for helping us understand the data set we had at hand, because we could see some patterns forming here, like the texts that are here in the bottom part, they are anonymous and they are very close stylistically. So one intuition might be they were written by the same person, right? This is what we already know. This is what we would think. But it turns out that these were all texts published by the same publisher, who had very strong editorial policies and enforced some patterns that were not represented in the rest of the data set. Or this small cluster here, these are also texts that we suspected maybe one person offered them because they are anonymous. And it turns out that they were translations from French. Made in early 18th century, late 18th century, when American soldiers who knew some French, they were just translating the stuff they liked. And it's not similar in any way, except for being bad translations from French by people who were not trained as translators. So there is a lot of calques that are visible in this language. It also helps you understand that some texts shouldn't be in this data set because maybe they are too short or too long and they are influencing your data set too much. So you can do this sort of mapping as an initial study, and then you narrow it down. So you take the short text, you take the long text, you take the texts that are clearly translations, you take the texts that are published by the same publisher, and you look inside this and start asking the some questions about this specific problem, such as is this author is this offered by one person or maybe by a team of people that we don't know and we cannot know anything. Of course, with historical data, there are always many questions for which we can and cannot find easy answers because we just don't have enough external information. And there is always the question that there might be an offer that we just don't know of because no evidence was preserved of their existence. So there are all these things to consider, but I mean, you have your expertise in your field, so I will not be teaching you about your fields. It can also help you verify your hypothesis. So let's say you have a very strong suspicion that some text was offered by a given person, like we had in the case of this anonymous Mexican play that we were examining. And using stylometry helped us attack the problem not just from the theoretical perspective and from close reading, but also verify the similarity to other texts and see that we achieve the same observations, we reach the same observations by using different methods. And this helps us be even more sure of something. And when gathering data, we already mentioned that it's very good to have the text of roughly the same length. So don't compare news articles with the whole book, because this will not give you good results. They will be deemed unsimilar and nothing surprising here. But it's also good to have roughly the same amount of text per author or per issue that you want to represent. Like if you're examining comedy versus tragedy, your corpus shouldn't be like 700 tragedies and 200 comedies, but try to reach roughly the same number per each issue. Of course, there might be some differences, but don't do huge differences because your results will be skewed in the direction of the more represented group. It's good to have the same formatting, spelling. So if you use text in British spelling, use all of them. Try to have all of them in this. If you're standardizing the spelling from, let's say, in the case of our Mexican play, we had a lot of F's marked as this, long or long S and so on. This often happens in older text. So make sure that if you standardize, like half of your texts have the modern spelling, then the other half should also have modern spelling and not the original spelling from the 17th century, because it will cause problems. And your data set should always represent the problem that you are examining. So if you're looking at gender differences, for example, try to have an even representation. If you're looking for looking at genre representation, try to have it even, and so on. And if you're looking at an authorship attribution case, always try to think about every single possible author that could have authored a given text, but also throw in a few authors from the related time frame just for reference to see if they also position well together or if it's getting chaotic and they also get misclassified. So that's it from me for now.
For now.
At least for now.
The syllables later, right? So
if we manage to oppose, or I will show you the slides.
How much time do we have? Like 40 minutes, 50 minutes. Okay, no, it's doable. I think I give 20 minutes for the keenness. And yeah. So, hi everyone. I have an announcement to make. People had problems with graphical user interface on Macs, right? With XQuartz. So you install the XQuartz, but it doesn't work. The solution to that, as in many cases of using computers, is rebooting computer. It should work after that. Oh yeah, always after installing XQuartz, you have to restart your computer. I forgot to tell you that. I think it's on the website, but yeah. Unfortunately, anyways, still sorry about that. Still solved, mystery solved. Rebooting computer, the ultimate. At least we don't need to hit it with a hammer, to solve things. So we will do a little bit of. So I'll just new share. We'll do a bit of the diversion to the side, and we'll talk about the word. The keyness of the words or the keywords, right? And many of you here, with some of you, I spoke that you have an interest not really in a relationships, right, within the large corpora, but like understanding what makes your text of choice. interesting or what specific like handling of the topics is there, right? And one of the classic old approaches to that in corpus linguistics is the search for the keyness, right? And keyness is very much related to aboutness of the text, right? This was noted by a linguist many times that, you know, any text, you know, if you take two different corpora, two different texts, there will be a difference between them, and this difference would be reflected with the relative, in the relative frequencies of words that were used. Obviously, this is a, intuitive concept, right? The text about cats would not probably won't have a lot of things to say about alien invasions. However, there might be some interesting combinations of those two. Anyways. But the problem is that it's easy for us, for example, to estimate as a human readers to estimate what is important for a text, right? Because we have a lot of previous training and exposure to text. We are professional text readers and text producers sometimes. So we don't need to rely on an external context, because our external context is our basically, it's in our brains. We have the semantics represented, the difference. So it's easy for us to tell that these words are somewhat important and somewhat interested for this specific text. But for computer, the reference corpus, so we can only argue about the difference if there is a reference point, right? The reference corpora. And the classic kind of this is a quote from the famous corpus linguist Kilgariff, kind of the patriarch of corpus linguistics and keyword measurements, right? That any difference will be reflected in a keywords list, but again, it is always be dependent on some context. So it's super important how if you choose choose your reference corpus as a text about dogs and compare it to the text about cats. You will have different words popping up as a keywords if you compare the texts about cats to the text about alien invasions, for example. I don't want to, it's not an introductory course to corpus linguistics anymore, but I just want to give you a general flavor of how things are done, and then introduce a very, very powerful way of tracing the significant or distinctive words for texts that is also implemented in Stylo. So it's not completely unrelated. There is a function in Stylo called oppose that you can use to oppose, but Joanna will talk about this later. Yeah. Function oppose that compares basically two subcorporas, two folders to each other, and ranks the words in accordance to their to the level at a level of their interestingness. Okay, so in classic corpus linguistics, there are generally two major approaches to keywords, to detecting and measuring the keywords. Is the effect size difference. Is basically, in one way, we just measure how much frequency is different in one corpus is different from the other, and a kind of significance testing, which is also dependent on the frequency. But here we use the corpus linguists use some basic notions from probability theory, and they ask how possible it is to have two frequencies of two words coming from two different corpora, drawn from the same abstract theoretical distribution. So there's also when we don't do the pairwise compos comparison, so we don't compare like corpus A to corpus B. There is another family of keyword measures, which are called, or sometimes they're called like dispersion-based measures, where you don't have like two corpora, but you have many documents, and you try to look at how the words behaves across these documents. So again, very quickly, without going into too much detail, I'll just give you a flavor of how the effect size difference, for example, is calculated. So here we have, let's say, two corpora, corpus 1 and corpus 2, the study corpus as it's called, and the reference corpus as it usually called. And there is like the red word wizard in the corpus 1 appears a little bit more, right, than this red word in the reference corpus. So the basic thing, I will skip this specific calculations. The basic thing that you can calculate is the ratio, right? The ratio of this word's appearance, and you can easily see the visual representation. You basically compare how much there is in corpus A versus the corpus B, right? You divide one by another and you get the relative difference coefficient. There's different things to do. So in the case when we do significance testing, this is the same corpus still, right? So this is the corpus 1 and the corpus 2. We built like a statistical model that we call it like expected distribution. It's theoretical, it's an abstract. It's basically like a weighted average. And then we ask like how possible it is to just draw this to observation in corpus 1 from this theoretical distribution and from corpus 2. Maybe there's actually not that much difference. Maybe the words in corpus 1 and in corpus 2 coming from the same distribution. There's a lot of work done to marry these two approaches because they will usually catch different types of words. So the effect size approaches would catch rarer words that are not that frequent, and the significance-based approaches, they will catch more frequent words that have a lot of significant, even the smaller difference in words that we observe many times would be significant by the definitions that they use here. Anyways, the interesting part for us is not, we will not do the effect size or the things with significance testing. The interesting part for us is the notion of dispersion. This is a very powerful way of looking at which words are important for certain texts and which are like overrepresented there. And this is some of you might heard about this, but there is also a very basic, like the industry, not anymore industry standard, but very basic, very popular method of like weighting words in NLP and computational linguistics, which is called TF-IDF. This nicely sounding sequence of words, which is translating as term frequency times inverse document frequency. Don't think about that too much, but basically what this method looks at is like how the words are distributed and in how much quantity across the collection of documents. Now we don't have a pairwise comparison. Now we have a collection of documents. And you see, for example, if we encounter a word which is much likely a function word, right? Because it is present in all of the 4 documents here in quite a lot of quantity, right? We just calculate in how many documents it is appearing. And in this case, it is appearing in all of the documents. So basically, we can say that this word is not that interesting to us because it appeared across the time, and we will not weight it at all, right? Because it appears across all the chunks. It's also very, very frequent across all the documents. However, if we encounter something like that, a word that appears, in a different pattern, it doesn't appear in all of the documents, it appears in some of the documents. So we also calculate like how does this word behave, not only its frequency, but also the patterns of appearance across the text, right? And so we assign this, the exact calculations are not particularly important. And so the good news is that dispersion, one of this kind of type of thinking, the dispersion-based metric, is also implemented in Stylo, and this is called the oppose function. And a post function does something similar, but Joanna will talk about this more, right? Great.
Immediately.
You wanted me to speak more?
No, I can speak now. Sure, no problem.
I can, if we will have time, I'll return to show you how to marry the word keenness and trees. Because trees are still related. One of the bigger problem in stylometry is that we need to have many times it's not interpretable, right? The interpretation, we show you trees, then you start using trees, authors are there and so on and so on. Then interpretation is the problematic part, and it's also a tricky part because there's many features simultaneously contributing to the relationships that you see on screen. So it's complicated to argue about that, but there's still a way to do that.
Yeah, I was just surprised because it was so nice to listen to your smooth voice and sip on my
everybody
coffee
was questions.
And just a moment for me to relax. Sure.
Sorry.
No,
okay.
I'm happy to talk about it. I already mentioned.
Sorry, there was a question.
Okay.
I think the question is like how different is different texts over time.
Yeah, because you were talking about it will also detect timing. Is that
no, I don't think.
Okay, but
just that at the pattern, I think like I detect the pattern of the distribution of words over documents, but you can easily use time to construct like chunks of time and then compare. So basically you say my corpus A is tweets between 2015 and 2016.
Okay.
You know, and things like that.
Okay, got you. Okay,
Yeah.
thank you.
Sorry if I confused you with timing.
More questions?
Yeah, no.
Well, probably there is some library or program for that. And actually, speaking of this, because we also discussed it over the break with a couple of people that, okay, so R is nice. How can I use it further? And there are lots of libraries for R, for various NLP issues and so on. So you can just search, for example, topic modeling plus R and see what kind of libraries are there for you to help you with your research. As long as you know about the method, there is a high chance that there is some solution. There are, for example, solutions for doing word vectors in R. If you find that this is a language that that is simpler for you to understand and you are more likely to build something yourself. One thing that will be super useful for you is that R is a very well documented language. So if you go to our documentation website, but even if you just Google R Stylo documentation, you get the website where you can find each function, like a small function that's implemented within this library, and then see the specific uses of it. But also you can get the whole documentation in the PDF. This is linked a couple of times in the training materials, so you should be able to find it. So some of you were also asking questions whether you can use it without the graphical user interface. And yes, you can. And there are actually some functions in Stylo that we are not covering that don't have a graphical user interface, for which you will need to have the longer command. And here you can find the precise information about this. So let's say I will just try to find Stylo. Maybe this is not a good word. Oppose. We will be looking at oppose soon. Yeah, so we have, we can see it both in the index, but also when we go further, we can see, so here we can see like various functions will be linked to stuff that it will be relevant to the issue of oppose, but we can just go directly to the function. To the function oppose. Where is it? Here. It is here on the page 40 something, right? And then we have, and we will have here all of the examples and stuff that might be useful for us. Yeah, it starts here. Oppose, contrastive analysis of text. So comparing groups of text. And we have the description of the function. We have examples of the usage. So you can see different options that you can change. And basically, if for some reason GUI is not working for you well, you can use it to find the relevant information and check how you spell something so that you can call particular parameters within Stylo function. You don't have to worry about this, but if you will need more advanced usage, this is something to consider. Not myself. I don't want to look at myself now. I can do that later. Okay, comparing groups of text. This is the last difficult run today. And it's not really difficult. So comparing groups of text is something that we often want to do, both in stylometry and especially maybe in discourse analysis and so on. So let's say we have two groups of writers that we want to compare and we want to check if they are really different, and if so, how they are different. What are actually the features that make them not similar? And this is where Craig Zeta, another method of stylometry, comes in very handy. In Stylo, it's implemented in the larger function oppose, which also have different other algorithms for comparison. And this is based on a very simple observation. And we spent the last couple of hours telling you that word frequencies matter, only to tell you now they might not matter in some other cases. Like for contrasting the groups of text, we don't care about frequencies that much. What we care about is the consistency of appearance of particular features. So we no longer want to know whether it's super frequent, but whether it's something that appears continuously. And think about it this way. These are two different types of distribution. The green line is the appearance of a particular word. Let's say it's a word ship. So if we have the word ship appear very frequently over the text regularly, you look at the first picture and what do you think this book is about? Yeah, it might be like Moby Dick or something, yes. Right? Like, I mean, 25 times in Moby Dick, I'm pretty sure they mention ship a lot more times, but you can think that probably this text has something to do with the ships because they are talking about them continuously, repeating and so on. But if you have the second picture, the very big concentration of the word ship, but only in one part, what do you think happens there? Exactly. The book is about something completely different, but at some point they go on a cruise and they are rambling on about this. And these are two completely different scenarios that we are seeing here. And the role of ship in these two novels is completely different. So we are interested in seeing this situation. So all these words that are frequently used, but only in one of the novels or one of the groups of text that we have. To do this, we divide our text. Of course, Stylo does that for us, but we divide it into even samples, and we see in how many sections of or samples the particular word appeared. And we see that in the first case, the word would appear in all of the 10 sections, but in the second, it would only appear in the 2 sections. So this word is less relevant for this book. And then we want to see how it looks in practice. You will have the access to this, but I will not tire you now with the exact frequencies. What you need to know is that for oppose, if you're not using English text, you need to mark the language or just put other in the corpus lang parameter within the function, because the GUI doesn't have this implemented. So you need to tell it, these are not English texts you're looking at. You have to reboot yourself, and now you look at all of the characters that we are able to encounter. Oppose function has a couple of parameters to consider, such as how big you want your samples, whether you want them pretty big or rather like look for super small. But usually if you choose like the size of samples to be 100, there will be very few words that you will end up with, and it might be difficult to do this kind of analysis. You might also choose if you want the slices to overlap. So if you want your text cut into even pieces, but there is no overlap between them, so where one ends, the other begins, or if you want to have some of the words to be present in both samples and have this kind of rolling window situation. There are also different types of methods to use. For now, I recommend Craig Zeta and different types of visualization, either markers or words. And this is why you have in your CLS Madrid Stylo folder the primary and the secondary set. The difference is here that because we're looking at 2 groups of text, we need 2 folders to distinguish between them. So you put some of your text in the primary set and some other text in the secondary set. Of course, it makes sense to make some hypothesis first, like how to divide these texts. So let's say by one author or by other author, and so on. And if you choose the words, you will end up with 2 lists of words. Basically, this is an example comparing female and male authors in 18th century and beginning of 19th century English literature. And this is one of these rare cases from the past where you can really see the gender distinction between the texts, because on one hand, on the left, you see, and let me see if I can make it bigger. Not really. Okay, I will read it for you. Forgive me. On the left, in the part representing words distinctive for female writers, so words that are consistently used more by female writers, we have felt, feelings, party, feel, feeling, cried, voice, exclaimed, idea, alone, scarcely, moment, attention, suddenly, seemed, carriage. So like lots of emotions and feeling, which we might be angry about, but this is what they were forced to write about in 18th century. And then we look at the male part and we see vow, honest, occasion, says, lay, above, the, case, sex, vi, reader, loveless, creature. So these words are more sort of plot oriented rather than emotion oriented. And we might be angry about this, but we're just representing what it was like in this collection. We wouldn't be able to replicate it for the contemporary literature because it's no longer so. However, we might still want to examine, like, I remember during one of our workshops, one of my students was comparing the speeches of Democrats versus Republicans and seeing which words they consistently used more often. So you might try that for politicians from your countries. I don't recommend, though. It's always boring and hurting feelings. We might not be interested in words so much, but just in seeing the general overlap and distinction, and then we can use markers. And then this is the same graph, but here you can see that there is a huge actually community of authors that will be sort of mixed. So the gender signal will not be visible for all of the writers, but still a lot of these samples will end up either more on the female spectrum or male spectrum and have this distinction. So I encourage you to experiment. It's a lot of fun doing this for different corpora. And this can be very helpful for us if we're analyzing discourse markers or specific vocabulary for particular groups, or if you want to see how distinct specific groups are and what's making them distinctive. And just a very short example in my also to loosen you up a bit, there is a break soon. So just fun example. In my TV studies research, I was curious of how different showrunners influence the style of the show. And I was examining Doctor Who, which is this British famous sci-fi TV show. And it's also famous because it was one of the first British series that included showrunners. So the person who was running the show, setting the whole tone. And this is the person who combines the duties of producer and writer. You can read more about this if you're interested. And I was looking at particular episodes and the language of particular characters, especially because one of the showrunners was accused that he's really sexist and that his female characters are totally bad, nothing interesting happening. They're always crying for help. And actually, this is a little bit visible, unfortunately. So in this, comparing this vocabulary, I could see that the interests are different, that one of the showrunners was more interested in the human component of time travel, of experiences associated to it, so also the familiar relations between people, and the other was more interested in having fast conversations and explaining stuff. But also that we have this group that mentions a lot of family members, mentions home, mentions emotions, and the other group of words from the other showrunner were the companions to the doctor, so the sidekick characters were actually saying things that would be supportive of him or asking him questions. So when you have the words like Mom used big makes mind, inside, kidding, planet, different, minute, human, earth, that, on one hand, and you have words like, hey, oh, please, sure, hello, fine, understand, already, and so on the other side, you can sense that there is something going on here. Of course, this is not enough to, build hypothesis just on that, but this can be a starting point to do a more detailed analysis. And then, for example, I would take these words and look at the collocations with these words in the discourse analysis part and see which phrases would they connect to and what it would tell me about the features of particular characters.
So this is amazing because this is what exactly I'm interested in doing usually. I'm curious to know how you got these words out of the show, because of a show, right? You said? Did you get the transcript? And then
yeah, I used transcriptions of the episode, so dialogue lines transcripted. Yeah.
Okay, so the dialogue were completely transcripted, put it in the corpus folder that you usually have, and then these words came out, and then basically you're doing the modeling and everything.
Yes.
Okay.
Yes, basically I used fan-created transcripts of the shows, and I proofed them myself. But basically, I had a separate file for each episode, and then I would also extract the lines spoken by particular characters, and then let me show you how, like in this folder that you downloaded, you should have the primary and secondary set. So then I would put in my primary set, for example, just the text by characters from a couple of seasons, and in the other folder, characters from some other seasons, and see what would be the differences between them. In the example that you have downloaded to your computers, you have the text from the 27 British novels divided into female writers and male writers, because this is still 18th century, so you can see some gender patterns here. And I remember one of you asked me about George Eliot, right? So George Eliot might be an interesting case here, because if you remember her in the Small British, maybe not the cat picture, but if you just look even at the 100 novels, you see that actually she's more similar to Dickens than to other female writers. And this is sort of consistent, that she will be more leaning towards male authors rather than female authors. But then you could use her and analyze her with these contrastive ways and see where she would end up, her vocabulary, who it would be more like, and so on.
How do you deal with irony? Just wondering how this works. Sorry. Okay. Yeah, that's my question. Thank you.
Yeah, good question. But like, what exactly about irony? Like, you mean ironical use of particular words in a post? Well, a post doesn't discriminate for you in a way, the vocabulary. So you need to, like, all this kind of analysis, it can be helpful to form you some observations, but you still need to look at it closer. So we always like to say that distant reading is not something that, like all of these methods of distant reading or computational literary studies, they are not erasing traditional scholarship, because in the end, this can help you pinpoint some of the points that you that are interesting, but you still need to sit down and look at it and analyze it. So you still need your expertise. Yeah. And I mean, for me, in this particular case, dealing with irony is simple because I've watched this show. So, so even though I'm analyzing it at a distance, I know it by heart almost from watching, reading, listening, and having examined it for a long time. So I know more or less which words are more associated with irony and which less.
So I had a question about the visualizations themselves. So I have a corpus and it's about 200 tags. They're not long, so they parsed really easily, but they're unreadable on the screen because there's just so many of them. So they all blob. Is there any way around? I did with points and that was great, but then I didn't know which text is which. So are there ways around a large text in the visualizations?
Yes. So when it comes to cluster analysis, you can select different size of plot area. So this is here in the output. You could make your plot height, let's say 20. And then this will help a little bit. But in general, when you have a corpus of 100 novels and more, it will be useful to just make a network out of it. And will you be talking about bootstrapping yet a little bit? No?
I don't think so.
Okay. So, so we can point you to some materials also, because this is a short workshop, unfortunately. But there are ways to easily make a network out of it, and then it will be much more readable. Like we showed you a few examples with Dickens chronology and so on. And then you have these connections and it can be a much larger picture. Of course, it will still have very small descriptions the larger your corpus gets, but it's easier to read than cluster analysis.
Yes, I have a question that is a bit about the workflow and a bit about, like I have to circle back a bit to what we did before, because what you showed us right now is like comparing two different text corpora. You cannot compare more of them, right? So you have to have a hypothesis. Because I have a lot more texts, I have to have a hypothesis about which part of the corpora I can compare, like to make sense. So it would be like a logical workflow to have a cluster analysis before and then see different clusters. And on the basis of that, I can then build a hypothesis on which two corpora I can compare. So now I have the question, is there a way in this, like the first, this dendrogram thing we made in the first place, to see at that point what the most significant like differences on a word basis are? Because I know there are. Oh, you are coming there. You are getting there.
No, I mean I didn't think I had the time, but now you asked this question. I like not to.
Thank
to
you
show
for
you
asking
that.
this
Thank you
question.
for
He really wants to show this.
Yeah, I really would like to know.
Yeah.
Okay. So this is a great question, and this is related to the problem again of interpretability of the trees, the interpretability of the relationship that we see. They are coming from different things. Again, that's not something that Stylo was originally pursuing. So I was like with my like mediocre programming skills, I was trying to build on top of that. And I in some of the slides and tutorials and scripts, you'll have some links to another like package that is just on GitHub. It's like a library. You can also download it. That is called C Trees, I think. That's exactly it's the name. It's sorry about the name, but anyways, I will show you the logic behind it. So share screen again. Right. So the basic idea is we started the diagram, right? So this is actually an example from our colleagues from Trier. They were working on pamphlets, French pamphlets, 17th, 18th century. So this is a very small example. There are 5 texts you see, and there's like also a few texts that are anonymous, and they're connected to this green, poorly readable Barnav author. So first thing that when you see the tree, first thing that you probably should do is not to trust a tree, right? Because the trees are tricky. The trees are hierarchically organized. So one way to think about the trees or to understand them better is to cut the trees. So that's exactly what we're going to do the last 5 minutes of the session, at least. All right. So at the beginning, we'll also see the logic behind like hierarchical linking in the tree. At the beginning, there's like 5 separate texts, right? 5 leaves, right? They are basically the maximum number of clusters here in this tree is 5, right? And then we see the first connection happens, the closest connections between the two texts by CS. And now we have 4 clusters, right? Overall on our dendrogram. So we can say that there are 4 clusters. The one cluster is represented by 2 texts. We can aggregate even further. At the next step, the next height of the tree, there's a cluster between this Barnav and anonym, and finally there are the 2 larger cluster between anonymous and CS, right? And then they are even more joined. You know, they're more joined in the end. So they're always in hierarchical clustering. There will be all clusters will be joined into one hypercluster. And the question is like, what is happening? Can we use this information, right, for inferring something about the relationship between the text or relationship between the groups? And we can absolutely do that. However, the thing is not it is not straightforward, and it will require like but basically what you can do is to look at the dendrogram and think about the dendrogram as it suggests you new groups, right? You haven't think before probably about the group, probably you thought about the group of CS, but generally, it is a suggested grouping with the blue cluster and the pink cluster. So what you can do is remember that there are words still underneath that, right? There are some words, there are some frequencies. So you can take your frequencies and run like association analysis basically on that. There's different techniques that you can use in this particular case, and the package that I use. This is like correlation ratio across different classes. So you can build the same analysis not only for 2 classes, but for example, if you cut dendrogram at 4 clusters, you can do it for 4 clusters, and you could get the words for associated with each cluster. So this particular example, right? So you can think about this as an emergent kind of class information that emerges from the tree itself, right? And so here we do the association analysis, and then we have the most associated. There's also the p-value cutoff, which might be not the best idea to do, but there's many ways to do that. Is just one implementation of that. And you immediately see the problem. This is also great for exploratory research. We immediately see, I don't know if you see actually the problem here, but basically the cluster 2, the blue cluster, is all the words with S, right? All the words significant with S. And cluster 1, the pink cluster, is one word that is significantly associated with that, and it's word fe. Remember, it's 18th century texts. So this is not F, right? This is the long S. The OCR. So these clusters are absolutely driven by OCR error, is OCR inconsistencies. In one text, they have the normalized spelling with S, and the other one is with the long F. So this could be a very powerful way to do that. And so if we go back to this text by Barnaf and Anonym, and we will look at the text, we will find a lot of fe instead of se. Yeah. So actually here you can see an example. So there's a GitHub, it's open. This is example of running this thing. It's very, again, it's, should be quite simple. Doesn't require much more than running Stylo itself. So you just need to download, to install another library through the GitHub this time, because it's not on CRAN. It's not available on the repository. And that's basically, you see the minimal example. The only thing that you need to do is to pipe the results from Stylo into the new variable in R. Right, so you can access other things from this. So basically, you save the output from Stylo directly in R, and then run the view tree function, where you can select how many clusters you cut it. This is also available in Stylo Basics RMD or Stylo Basics IPNB in the what was it called? In the Google Drive, so you can find those bits of code if you're interested.
It's a lot of fun.
It is a lot of fun.
Time is up. So.
Time is definitely, yeah. But okay, thank you very much. So this is, I guess it is from us with Joanna. Next session would be might be also like popping in, but with the professor.
Yeah. We can stay on the chat. Yeah,
we can stay on the chat, and we are always available. You can find me on Twitter. You can find Joanna on Twitter, or you can email us the old-fashioned way. I mean, Twitter is not the best place to be, to be honest.
No, not anymore.
Not anymore, definitely. So, thank you very much, beautiful audience.
And good luck. And, tell us when you do cool things. We're always happy to hear about things that people do after tutorials and so on.